All right, we are going to do a sports application, example number 3. What it states is a lift on a ski slope rises according to the equation A equals 130t plus 6,250, where A is the altitude in feet and T is the number of minutes that a skier has been on the lift. 5 friends are on the lift. The 5 friends are Anna, Tracy, Kawani, Tony, and George. What is the altitude of each person if they've been on the ski lift for the times listed in the table? Here are the times for each person. Draw a graph that represents the relationship between the time on the lift and the altitude. So, couple things. We have altitude, and altitude, that is our A here. A is for altitude. Okay, A is for altitude, that is our A. And then we have the time, and the time is the T. Now, in this equation, there are no X's and there are no Y's, but what we need to remember that the T is actually the X, or the independent variable, and Y is A, the altitude, is actually the dependent, or the Y. All right, so we are just going to go ahead and get started with that in mind. So first we're going to create a table. Actually, I want to read this question one more time. It says 5 friends are on the lift. What is the altitude of each person if they've been on the ski lift for the times listed in the table? So this is actually the question that they're asking. We need to figure out. And there's a lot of information here, so I want to highlight the question so we know what we need to answer at the end. So what is the altitude of each person if they've been on the ski lift for the given times? And then draw a graph. So we will do that. All right, so let's get started. I'm going to go ahead and create a table. The first part here is going to be my time, which is really the same thing as X, okay? So my times are going to be listed there. Then I'm going to have to figure out what the altitude is for each of those times. And this lovely formula gives us the altitude. So it says the altitude is equal to 130t plus 6,250. I'm going to give some space right about there to do all that. And then I'm going to come up with my answer, which is the altitude. Probably give some space. Those numbers might be big. And then lastly, our ordered pair, which is going to be TA, which is the same thing as this is our X, this is our Y, and this is our XY. All right, so we're going to go ahead and put in our time. So Anna was at 4 minutes. So we're going to figure out what the altitude is if she rides the ski lift for 4 minutes. So we just plug in 4 for T, and we get 130 times 4 plus 6,250. So order of operations says you're going to do that multiplication, and then you're going to add this number to whatever you get there. And what you end up with is the value of 6,770. And I'm just going to go ahead and write down what these, because I know that you guys can do this multiplication and addition. So that gives us the ordered pair for 6,770. All right. Then we're going to do, so that's Anna. She, what does it say? What is the altitude of each person if they've been on the ski lift for the times listed? So yeah, Anna's been, the altitude, if she was on for 4 minutes, is 6,770. Okay, let's go on to the next person. We could probably just write that. We could say, over here off to the side, we could say Anna's altitude. Anna's A equals 6,770. There we go. Okay, on to the next one. Let's do Tracy. Tracy is 3. So we're going to go ahead and plug it in to find the altitude. We stick 3 in for T here. She's been on this ski lift for 3 minutes. And again, you're going to do the multiplication and then add it to 6,250. And you end up with the value of 6,640, which gives us the ordered pair 3, and then 6,640. Okay? So that means that Tracy's altitude is actually 6,640. Then we're going to get to Kawani's. Kawani was on the ski lift for 2 minutes. So we just go ahead and substitute 2 in there. And we do the multiplication and the addition, and we end up with 6,510. All right, so that is Kawani. So Kawani's altitude is 6,510. And then there is Tony of 1.5 minutes. We're going to go ahead and substitute that in, which would be, what do we get there? Oh, this is 1,050, which would be 6,445, 1.5 seconds, 6,445, and that would be Tony's altitude. Okay. And lastly, there's George. So George is on there for 1 minute. The altitude is 130 times 1 plus 6,250, which is 6,380. So that means that George's altitude ends up being 6,380. Okay, great. We have all of the altitudes for the given times for all of the people. Now what we're going to do is graph this data. So we have these ordered pairs right here. I want to make sure you can see everything. Perfect. Okay. So for each one of these times, we are going to graph the data. So for here, I'm going to start with this one right here. Now, what I want you to notice is that our x-axis is actually our time. So this is our t, and our altitude is actually our y. So this is our a. So our altitude is here, and this is our time. So we're going to go ahead and graph these points. So the first point is 6,770. So we're going to go over here to 4, and then we're going to go up. Now look at here. It's really, really hard to graph something that's 6,000 or something. So what I did is I made a line and then this little squiggly. That means there's like a little break in the line. So what I'm doing is I'm going skip, and I'm going to go up to 6,200, 6,400, 6,600, 6,800, and 7,000. And that's okay to do with graphs when you're dealing with these really, really big numbers like this. Okay, so here we go. 4,606, I'm sorry. This is 4, so the T is 4. And then the altitude is 6,770. So that would be, this is 666, 7, and it would be like a little bit over this. So if this is the 4, this is 67, it would be somewhere, probably over half, somewhere around there. And I'm approximating. Okay, the next one would be 6,640. So here is the 3 minutes, and it was right here and a little under half, so right about there. The next one is for 2 minutes. It was 65:10, just slightly over 65, so right about there. And then for 1.5, ooh, this is fun, 6,445. So for 1.5, that's between 1 and 2, it was 6,445, so just about half right there. And then for 1 minute, it was 6,380. So this is 1 minute, 6,000. This would be 380 is close to 400, so probably about like right there per se. And if we graph this line, what we end up with is a linear relationship. And this linear relationship could be used to really predict future altitudes if the minutes continued. All right, so we are going to do this again, except you're going to do it, and it is time for our lovely friend, the Pause Dragon, to come. You are going to do, check it out, example 3. Go ahead and work this problem out. Go ahead, make sure that you make a table like we did, and make a graph, and then answer the questions, what it's asking. So here we go. It's time to pause, work out the problem, and then we'll go over it in a little bit. See ya. Good luck.